Today I'd like to talk to you and show you the unboxing of the industrial controller I've purchased to replace Mach3. As you can see, fairly big, about 20 kilos. It is the part number for the controller is a SZGH-CNC4A 1000TDB-3, and also has a control panel with it. This particular model is a 3-panel, and it's from Shenzhen Guanghong Automation. Sorry for all the Chinese speakers out there, that's the best I can do. So it's come. Australia must be a small place, and my YouTube channel must be a lot more popular than what I thought, because the address is just Peter, Australia. And here it is. Now, as you saw in the previous video, the first one, where I went and showed you the lathe and explained a few things to you, I don't really know what's in the box. I know there's the main panel and the control panel. There'll be cables. But I don't know what are on the ends of the cables. Are they bare wires? Are they some type of connector? I don't know. So this will be a surprise for me to open up, just as much as what it will be for you. Also, we'll give you an idea of size, and we'll discuss the parts that I need to get, and as they come I'll do an unboxing and a information video on them, explain why, and then there'll be videos on the parts and the fitting of the machine. But as always, 1,000 views, it will get the next video to come up. So if you want to know, spread the word. If not, just watch the first video a few times. Okay, now as you can see, all been nicely wrapped up. Got a big band on there, but as you can see when I run my finger, there's no seal. So there's no flap. Only one flap up the top. Slight damage, been pushed in the air. Obviously there may be cables in there, so we'll see. Just get the trusty knife out and we'll just go through. Okay, that's the bottom end. Okay. Alright. Here's the cable. Just cut in cables. No stripping, no soldering, no bare exposed wire. They have a series of DB plugs. They have your common ones, 9s, 15s, 25s, but then there's some odd ones, 26 and I think and a 40. On the plug-in, they've got the code. CN is the connector, and the number 10 is on the back panel. You'll see a 10. Also, very professionally, they've actually wired each cable, tagged each cable. That one's Z, 0 volts, alarm 2, and that will match your wiring diagram. So we have that cable, system cable, CN9 again, larger black cable, maybe just the earth. CN4, another system cable. Systems are for the relays and all that. Mach3, you would program the code to go to one of your pin numbers. The pin numbers on the controller have a corresponding M code. So let's just say, for example, this is M71. So in your G code, you only have to put M71 and it will trigger the signal. So that's starting to get away from programming yourself to an industrial controller where a lot of the customizing has been restricted. It's set, bang, 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 this is what you have to do, that does that. So you have to work within those limitations. It's not as free and easy, but it's also regimented, but that's what industrial means. You buy that, it will plug in there because that pin has to be that, that pin has to be that, that pin has to be that. So it's not based on the whim of the end user. Here's your main power cable without an end. Now depending on what this is connected to, they've supplied some other additional DB plugs, because some on the back of the panel, which I'll show you when I get to it, are male and female. CN5 is actually 3 cables in the one connector. So as you can see, top marks for the cabling so far. One thing good about these unboxing videos, I find them boring myself, because they're usually, oh wow, look, it's a cardboard box. Oh look, it's yellow. Absolute wank. It shows you what's in there, what comes with it, how to repack it, all that sort of thing. Here's the manual. Manuals. That's a controller. They have a lathe and they have mill specialised controllers. Elaine Chen, she was a sales rep, very helpful, very informative. If you mention you watched this video with the wizard and contact her and tell her that, she'll look after you. The programming guide, you can get this on PDF as well. It's a hard copy, good hard copy. Operation of the panel. So here's a box and the cabling is bopped on and squashed that down. So then we have the 2 panels. So that's it, is unboxed. So if you want to switch it off now, that's fine. I'll go to the unwrapping. So that was unboxing. So then this will be the unwrapping. We've got the cabling. Got our manual. This is the connector cable between the 2. Now as you can see, fairly large controller panel. These are the CNC lathe and turning controllers. That's the 990s. These are the 1000s. And as you can see, they have more complicated, more expensive controllers as they go up. So this is mine here, and that's the default controller. Now, because my automatic tool changer runs off a stepper motor, I had to go to get the -3, which means 3 axis. So it's got X, Z and C, or Y. That is because I want to run that. However, the smaller version only comes with the automatic tool changer built in. This has got it built in as well, but it's for DC motor type. You know, those ones that will just rotate and flick a pin and the tool moves to the next one. So that, unfortunately for me, wasn't any good, and I had to spend extra money to buy it. So here's the panel. And this is where 4K comes in. You can zoom in on the image and pick up what you want to see. So just a press button board, jog button looks like, and that's your feed rate override. It is all predetermined in the controller, hard coded into the PLC ladder. So you may want, you know, this particular one. No, we give you 10, 20, 30, 40, 50 or 25, 35, that's it. You're stuck with it. If it's good enough for industrial equipment, should be good enough for us. Now the dimensions on the panels are a bit wonky. You draw them up and then you think, wait, how can that fit in there? It's supposed to have a screw there, but you've got overall dimension. So the panel is lay flat, so the cutout for this can be a lot smaller. Overall footprint. You can connect it to the computer, the RS232 I think it is, and a USB. Not only are all the plugs labelled, as in the CN numbers, but all the terminals, the pinouts, are there for you. So you can see exactly what is connected where and what it's called. 24 5-volt power supply. I didn't think it was that elegant. I thought they could have incorporated that inside, but all the different levels, because this is 3 axes, the back changes. It's not just one panel though, the front looks similar, the back changes. So these might be here, or that might be over there. So it all depends on what back you get, where this power supply is and all that sort of thing. The other thing too about the website, it has the photos for one controller listed under the other. So if you look up the -3, they'll have -2 photos, and you look up -2 and they've got -3 photos. So just a little bit of improvement there. Position feedback. What's position feedback? On Mach3 you have your up limit switch, your down limit switch there. Then you have your home switch. You have a stepper motor controller, and your breakout board and Mach3. So Mach3 says, right, I want you to go 1 inch, 25.4 mil, that's 7,000 pulses. So Mach3 says, okay, here's 7,000 pulses. Down it goes to the stepper controller, says, okay, you're at 16 microsteps, you know, blah blah blah, you got a 2-1 ratio, sends that. So the stepper motor spins around and drops steps, or, which is the trouble I've been having, is feeding, then it jams up, and so it's think it's moved 1 inch, but it's only moved 3/4 inch, or 0.79, all this sort of stuff. So what position feedback is, and this is one of the main reasons, 2 main reasons I got it, but this is one of the main ones, is that you can connect your linear scales to it. Those long glass scales. So you put them on your manual machines, and there it is. Inch is 1 inch. So it says, right, we're going to go 1 inch, and it's only 970. Comes back, hey, I've only moved 970. What's going on? This is what I have to find out, is what happens. Does it send another 30 pulses to get it to move that distance, or does it just stop? Come up with an error. That's what I have to find out. So, but that's why I went for that. You can't get that on Mach3. That's for the main panel. Everything's 24 volt. Well, not everything, but industry's 24 volt. So a lot of this stuff you have to work out to be 24 volt. So scales and all that fine, but yeah, you have to check. MPG fits in. Again, these are specialised ones. These are not TTL. TTL has a square wave like that when the pulse is. These are RS422s. So they have a positive pulse and a negative pulse. So when the TTL goes like that, for home or whatever, you have that signal. But a RS422, it has the negative one, so the actual signal measurement is double. So if you have interference, you know, all that sort of stuff, it can become more reliable. So you can buy a MPG controller, TTL might be 50 bucks, RS422 might be $100. So everything you buy is going to be more expensive because it's better and it's more accurate. So that's that connector. Now, here's the tool change. I've got an 8 tool automatic tool changer. So this sends out 24 volts, and it's also got 8 pulses that it can read back when the tool is in the correct position. If it's not in the correct position, it sends an error warning. So if you can set yours up to use that, you can buy the cheaper 2-channel one, 2-axis one, and go right ahead. X, Y, and Z drivers, that's for your stepper motors. It's got an alarm on it. When I discuss the stepper drivers I bought for it, you'll understand. Spindle encoder, that's the other thing. People have trouble. Some people have no troubles in the world about anything. The rest of us, we have troubles. And threading is hit or miss with Mach3. Depends on the hardware. And some of it works, some of it doesn't. Some of it works some of the time, sometimes it doesn't. So that's why. Threading and accuracy. That's why I've gone for this. So you have a spindle encoder. On Mach3 you had one signal and it went pop, 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 pop. This is a normal incremental encoder. So I'm putting a 1000 pulse one on. So it's checking the signal 1,000 times a rev. So it should match the speed and all that a lot more accurate. Should. Proof will be in the pudding. So that's the tool, handheld box. And these are your inputs and outputs. For those cables, we'll have M61, 65. You can look up the book and you can't find half of these. But so some of them are for your limit switches, some of them are for your coolant and all that type of thing. But you just call it up in the code. How you then write the code if you want something different. That's a journey I'll have to go along. So on the front of the panel screen, sort of a little bit, function buttons as per normal, reset. Now, I'll show you later a video about A, B, C, D, E, F, G, which way your finger has to go to follow it. So you have your normal code alphabet and then shift for the smaller ones. Your menus in here, parameters up, numbers. And again, some of the buttons will be, you can do a speed change and it will be preset in there. Page up, and that's just the coding. So as you can see, there's a numbering side, there's a lettering side, there's the menu side, and the menu control side. And they got different darker greys, lighter greys. So that's the size screen you have. I don't know if you ever had plastic covers on stuff before, but after a few starts, your fingers have worn a hole into the plastic and all the coolant's getting in there anyway. So it looks like you can just unscrew that, pop the license plate frame off and just put a new bit of plastic on there. So that's good. Unusual type of emergency stop. If you looked at my other videos, I actually put a light inside the stop so that you can show, especially when you've got different stops on the machine. So they normally have one panel, you know, normally open, normally closed, so it's already pre-wired. So to give you an idea of how big you need to make your panel up to sit on your lathe, that's the minimum size, and that's wider than my headstock and pulley guard and all that, and also stands about that high, so is it going to sit there? So what I'm thinking of doing, again, this is a journey. I haven't done all this and then come back later and cut out all the errors. All the problems I'll show you are the problems I have. All the help I get from the engineer and all that, I will show you. Everything I learn, I will pass on. So the idea is that maybe I could make up a panel whereas it just slides up and may slide in and slide out and hinge down and hinge up. Because it may be easier to find a box that size or make up a box that size than what it is to make up a box that large. So that's the unboxing, a brief overview, and as I said, we get 1,000 hits, we move on to the next bit, and each section as I do it, I'll show you and I'll explain it to you, what I do right, what I do wrong, what traps to look out for. And it is a big investment, don't get me wrong. Controllers around about $1,000. The encoders, rotary encoder for the spindles about $40–50. The linear scales will be $300, $350. So, and I only got two of the stepper drivers. They're about $80 each, so $160. So you add it up. If you've got $2,000 in your piggy bank and you've got a machine already set up for CNC and you want to swap it over to this, you will have some change left out of $2,000. Maybe it may cost you $1,500, depends. All what I'm changing is the encoder, glass scales and the stepper drivers. MPG, it's a video side MPG. MPG is about $240, fairly expensive. If you want a stack light, think about it, yeah, it's got the stack light on there. Think about putting a stack light, that's $30. So all your little tidbits come up. But then it's ISO G code. So basically any CAM software that you use will program this. So no more looking for, oh, have they got a post processor for this or for that? It's all ISO code. And then the other thing too is that the controller, it has its own sort of codes. So if you're going to rough out a bit of stock, you can put in a dimension and it will work out the roughing cuts for you. So it's got a few time savers in it, so it can work solely on ISO code or it can work on some of its own code. Bit like this Siemens 808Ds and all that, very similar. And the macros, they're all hash a number. So you'll see all this coding isn't in your normal English like you would with Mach3. So it's going to be a learning curve and I'm looking forward to it, and it's revitalised the batteries. So again, for those 1,000 people out there, thanks for watching, and all those who subscribe, you can ask me a question and I'll answer it for you. So hopefully there'll be another video after this. See you then.